Welcome to week 5. This week we'll begin working with functions. We are still in chapter 4. We've already done a couple of instances of just traditional functions. That's snippets of code that run at a given event. The event could be user driven, but what we haven't gotten into is the new ES6 arrow syntax. We haven't gotten into too much on arguments, so we'll be doing that this week. And then next week, week 6, we'll be doing more on events. So let's get started here. So the syntax for a function declaration is important. We have the word function here, and then the function name, and then parameters inside parentheses. The parameters are values that get sent to the function because the function may need to run them. Now keep in mind that as long as JavaScript has access to elements, often we don't need to use arguments. Only use arguments if you need them. In other words, those parameters, only use them if you have a reason to use them. Don't just assume a function will need parameters until you get the hang of exactly what they do. And then inside the curly braces will be statements that run when that function is executed. Now this is a little bit of a review. We've already been through this. You're going to see this week, in fact, that the homework that's due will demand that we have a function driven by a user-driven event. And most of our homework will be the same way. So a function declaration that has no parameters and that does not return a value is shown below. Here we have a function called showYear, which has a constant called today. It's a constant because it never changes. The fact is today will always be equal to the new date object, so today will always be today. And when we alert this year is, and we concatenate the value, today.getFullYear, you'll see that this will alert whatever the current year is. So we call that function just by calling showYear with the empty parentheses. Again, no argument is passed in this example. Next, we have a function declaration with one parameter that will return a DOM element. In this case, I have function with the $ selector, and we're returning document query selector. And the way I would call this is to use const email1 equals email1 value. So if you look, we would return that value. We're going to see this in our source code from this week's materials. So again, just keep an eye out for the $ as a marker for a selector. So right now we have a function declaration with two parameters that returns a value. We have function calculate tax, which takes two arguments, subtotal and tax rate. We have a constant called tax. It's constant because it equals the same thing every time. It's not changing within the bounds of the script. So we're carving out the least amount of memory because we don't need to change it. So const tax equals subtotal multiplied by the tax rate. Now that tax rate, if we apply the toFixed method to two places, we'll have formatting for currency, and we can return that value. So how do we get those values? Well, in this case, we can have two variables that equal the arguments necessary, subtotal, which is $85, and tax rate, which is 5%, 0.05. So the tax itself will be equal to the calculate tax subtotal times tax rate, which would be 4.84, $4.25. So if $85 gets pushed to the subtotal and tax rate is 0.05 and we multiply those, that would be $4.25 and our sales tax would be $4.25. This is an example of a function expression. In this case, we actually create a variable, in this case constant name, that equals the function. So it's all the same formatting and syntax as a traditional function, but we apply the equal sign to assign it the value of the function. And then we have a variable. Now the variable should always be a constant because it's not going to change. Now similar to the function shown a few slides ago, this is a function expression that also has no parameters and does not return a value. The only difference between this one is that we have a function and then it's applied and assigned the value to the variable showYear, And then we still call the show year function, but we're actually calling the variable that equals the function expression. So when we have a variable that equals a function, it's still called a function expression. And it still has the same syntax other than the fact that it was assigned to a variable. Now, similar to the last function that had one parameter that returned a DOM element, this is a function expression with one parameter that does return a DOM element. So we have a construction $sign, or a constant and just the $sign that equals the selector. So what we're doing is returning the value of any div or any element that has the ID of email_1 and putting it into a variable. So the $sign now can be used to select any value by its class or by its ID. And lastly, this is a function expression with two parameters that returns a value. So it's the same as before, except this time we have a constant calculate tax, and we call it with the calculate tax function call and pass the two arguments. So the sales tax itself equals that function. But again, it's an expression this time because it has a variable that has been assigned the function. Now, time for the ES6 arrow syntax. So this is a shorthand for the ES6 method of doing things. Now, the ES6 means ECMA script. It means that 2016, the last number 6, is why it's called ES6. It was a major change in adding shortcuts and functionality to JavaScript. Traditional JavaScript, most of the JavaScript which you see online, which is slowly being replaced by these shorthand techniques, won't have the arrow syntax. The arrow syntax is honored by all modern browsers when we work on that, but the older browsers will not honor it, which is why you still see some stagnant ECMA 2015 out there. Now keep in mind there's also ES7, ES8, ES9. All those are versions of JavaScript that were released in the years in which that last number was done. So 2019 would be ES9. But those changes were very little. The big change is ES6. And that's what I need you to know. So this is an arrow function with a function expression. So we have constant name equals, and inside the parameters we have, inside the parentheses we have our parameters, and then the function call. So you have a variable equals, then the arguments that get sent, and often that'll be empty, then the equal greater than, which is the arrow, and then the curly braces. So if we have the function expression in the middle block of code there, where const calculate tax equals, and then the function call, and we'd call it with calculate tax, we would rewrite that as const calculate tax equals, then the two arguments, then the arrow, and then the same block of code after. So that's the shorthand arrow syntax. And it just takes a few tries, a little bit of practice to get this thing going. So this is an arrow function with one parameter. We have calculate tax equals subtotal. Now notice how there's no parentheses around the subtotal. That's because there's only one parameter. If you look here, we have parameters with parentheses. Now we have one parameter, so it's just equals, and then the value, and then the arrow, and then the curly braces. So our example is the calculate text that equals subtotal. And in this case, we're just going to use the subtotal times 0.074, which is the rate of tax in this case, with the formatting the to fix to. Now, an arrow function with no parameters that executes one statement would just be the empty parentheses. You can't just leave it empty in the middle. You have to put either one parameter, two parameters with parentheses, or empty parentheses. And in this case, we can call that function by using const URL equals get current URL with the empty parentheses, which is the same as the function call we used prior in the ECMA 2015 and before that. Excuse me. Okay, so the terms related to our functions. The function, again, is a block of code that executes. Calling, it can also be called invoking a function. The function declaration is how we declare it. We could use it with the keyword, we could use it with the arrow syntax. Parameters are values that get sent to the function. Arguments are the values of those parameters that get sent. Passing parameters is how we send data to the function in order to do something. In this case, we used a subtotal and a tax rate. A return statement is when we actually return a value, meaning we're not doing anything to it, we're returning that value. We're just sending it back to the caller. What we do with that caller will be up to the code. Okay, so a lot of times when we do like form validation, we might return a false or return a true just to figure out if something had been valid or not. Oops. Hoisted or hoisting is JavaScript's default behavior. And when we hoist a variable, we move it to the top of the script or to the top of the function where it needs to be. So hoisting means just simply lifting all your variables to the top and working with them, declaring them with let, const, or var, and then making sure that they have access to where they need to be accessed. So we hoist variables to the top of our functions, or we host them to the top of the script if they're global. A function expression is a function call where we have an assignment to a variable. So the variable will equal the expression itself. It has the same syntax as a regular function, with the exception that it gets assigned to a variable. And when we call that variable with parentheses, we're invoking that function. The arrow function is what we taught for ES6, where you have, instead of using a function name, you have an expression that equals the arrow syntax. The arrow operator is the equals and greater than symbol, which basically invokes the curly braces of what the code block that needs to execute. Now, let's talk about global variables. In this case, we've got a tax rate that's var. We're declaring it for global use. And when we use var, it adds the tax rate property to the window object. Let does not add anything to the window object. Let, because it's not part of the window object, will release the memory of that tax after whatever construct it's working with finishes. So if I use let in a loop or a condition, after that condition or loop finishes, the memory is released because nothing is in the window object. It's in the variable itself. So if we alert window.taxRate, tax rate would have a value. If we alert window.tax, it would be undefined because it's using the keyword let. So if we have a function that has a subtotal, like calculate tax subtotal, and we're passing that subtotal, we would want to use global variables. So tax would equal subtotal times tax rate, and tax equals tax.toFixed. Notice how tax is declared inside the function. So calculate tax of 100 and we alert to tax, the tax outside will have the variable. Now notice we didn't declare anything there. We didn't do a var, we didn't do anything. We just have tax equals everything. Tax equals subtotal times tax rate, or tax equals tax.toFixed 2. When we calculate that tax will have a variable. We've changed the value of tax inside the function. And that's a global variable. It's accessible globally. It's accessible outside of the function expression. Now, this is a function that uses local variables and constants. So what that means is by declaring const in the tax, it's only used locally. So if we have const calculate tax, subtotal tax rate, etc., and constant tax subtotal times tax rate, return tax.toFixed, when we pass the two arguments in alert tax, we'll have a value because we've returned the tax.toFix. But the fact is the tax does not have global scope here. We're just returning it inside the function. So if you're asking yourself, why would we return something? That's because we want to release that memory, because at that instance, the tax equals that value, and therefore alert tax will equal the value that got calculated. It will not be undefined. And you can try this. You can try this on your browser. If you copy and paste this and put it in the console, you'll see that even with the constant declaration of tax, we will still get the value. Now, if we look at the function with two loops, and we traditionally so far have been declaring the initializer of a loop with var, that's function scope. It's basically declared globally. If we do var I equals 0, I less than 5, I plus plus, the traditional loop, I will be in scope and it will actually display the value that you need. So it's going to display 0, 1, 2, 3, 4, and I would be the 5 elements that get displayed. Now, if you do let j equals 0 and j less than 5, j plus plus, and if you look at the closing there, there's actually an extra curly brace here. Let me just fix that. These PowerPoints actually came from the text. J will not be have a value here. In fact, let's just take a look at this. I'm going to actually copy and paste this into our console so you can see what I'm talking about. We'll experiment with both of these. So we have a const calculate tax. Watch what happens when I alert it. It works fine. And that means we've returned this. So if I did non-return, we would get nothing. So let's do the same block of code. And what I'll do is I'll just change it in the PowerPoint real quick. So watch this. If I remove the return, we will not need, see undefined, we lose that value. So I'm going to cancel this and then we'll look at the other two blocks of code too. Now the function that's still in scope here is this right here. Okay, so I'm going to paste this into this section right here, and let's alert I, and we get the unexpected token like this section right here, which is we can fix in. Let me just open up Sublime. Oops. Here we go. So what we're going to do is I++, right, and function scope, just so we can see it. We're going to lose this comment here too. So we're just going to change this to let in a second. So watch when we do this. See how it's 5? Because at the end it keeps its value. Now when we go back to our code here and we look at let, j will no longer be in scope. So what I'm going to do is we'll do let here, and now watch the difference. Because let is not part of a window object, we lose that value. So watch. Here's 5. There's alert right there, and let me go back. That's actually because I had an I already in there. That's why it was 5. This is actually block scope. So what we're going to be doing is we've got the let, and since we already have j here, we're just going to empty this. And now when we do this, you will see that it's a reference error because j is no longer defined because it's let. Let released the memory, and that's why it is the way it is. All right, so let's move forward. Just to reiterate what that experiment was about, it's about the difference between local variables and constants. So in var, the variable I is part of the window object and it's accessible globally. That's why after the loop, closing brace, I had a value. Then I pasted I again and it showed 5 because the I had already been defined. But with j was not defined. J is in let. So once this closing brace pops up, j no longer has a value, and that's why we get a reference error. All right, so as far as scope, we've got scope means where variables have value, whether they have it globally or inside a function, or whether they're a window object or not a window object. So where do we have access to our variables when they get declared? You want to declare variables only with enough memory for what you need them for. A global variable is accessible everywhere. That's the var. A global constant is done with const and it's not changing. A local variable would be a const inside a function, and what we did was we gave the return on the tax, which is what function scope is. Function scope means you return the value of the function and still release the memory of the variable. So the function has the value when it gets called, but doesn't hold the memory of the variable throughout the whole script. We also covered the local constant, where const equals something, it's unchanging. So var and consts are all dependent on how you want to use the variables. For the most part, we generally don't need var. It's only rarely that we need it. Function scope is when the variables, again, return inside so that you have the variable, and the variable only retains value within the function. And block scope means it's the let. The block would be a code block, like an if statement or a loop. And it was our last slide where we looked at it, and let had released the memory when we did a for loop, and j had no value after the for loop. And that covers this section of functions. It's a lot to digest and a lot to practice with. So this week I want you to look at the files, look at everything in the module 5 folder, and get a good glimpse of where the variables lose definition. I will be, from here on out, looking at your homework to see what types of variable declarations you use and whether you're using efficient memory in your code, because your code portfolio should have it. When we get to WebD 191, we will look at your code in the portfolio and make sure it's as efficient and ES6 based as possible.